So this is the final type of proof by induction we're going to be covering, and it's inequalities. So the way this works is slightly different, and I'm going to go through this one pretty carefully because inequalities tends to be the wonky one, I feel. So we're told to prove that x factorial is greater than or equal to 2 to the power of x for all x greater than or equal to 4. Okay, so we're going to start. X is 4. So 4 factorial, we're going to see if it's greater than 2 to the 4. 4 factorial is 24, greater than or equal to 16. Therefore true for x equals 4. Okie doke. So next step is letting x equal to k, or assuming if you let x equal to k for k greater than or equal to 4, we're going to have k factorial is going to be greater than or equal to 2 to the power of k. Awesome. Okay. So for 3, x equals k plus 1. We're going to have k plus 1 factorial greater than or equal to, or just greater than 2 to the k plus 1. For k greater than or equal to 4. Okay, so this is where it gets a bit weird. Expand this factorial, we get k plus 1 times k factorial is greater than 2 times 2 to the k. So what we can say here is that we know k factorial is clearly greater than 2 to the power of k. So this k factorial and 2 to the power of k link in with stage 2. So we can clearly see that we've assumed that the k factorial is greater than 2 to the power of k. So what do we do from here? Well, if k factorial is greater than 2 to the k, then we have to see that the scaling factor is essentially bigger. Okay? So what we're going to do from here is, if k factorial is indeed bigger than 2 to the k, we must show that 2 to the power of k times k plus 1 is greater than 2 times 2 to the power of k, because of this linking in with this. So we're now going to do a bit of steps. Well, we know this 2 to the k's are going to cancel, and we're just going to have k plus 1 greater than 2, so k must be greater than 1. Now, why is this true? Or how on earth does this work? So this k greater than or equal to 1 is really kind of like a fake lower bound. So obviously this isn't going to show that the 2 factorial is greater than 2 to the 2, which it isn't, because 2 is not greater than 4. What this is really saying is, if we've assumed that the initial case is true, and if we arrive at this, we know the initial case is true, and for all cases above the initial case, it's going to work, because of all valid values of k, which link into valid values of n, it's always going to work. So inequalities are really weird. I would recommend practicing them a bunch. So therefore, true for x equals 4, and assuming true for x equals k greater than 4, proves true for x equals k plus 1, therefore true for all x greater than or equal to 4. And that's the proof.